Welcome to The Explainer. Man, I am so excited to have you here today because we are diving into a truly fascinating intersection of complex physics, network theory, and the modern justice system. We're looking at a real-world scenario where the laws of statistical physics were actually brought right into the courtroom to challenge our fundamental understanding of cause and effect. So, let's get right into it.
So, here's the massive question we are tackling today. Can one tiny retweet genuinely cause an entire society to collapse? I know, it sounds like a crazy sci-fi movie plot, but this is the actual center of an incredible defense case. We're looking at a man, Dr. Chen, who used complex systems physics to defend himself against a charge of causing public disorder. He basically argued that, scientifically speaking, his single micro-action on social media could not possibly be the cause of macro-level chaos.
To immediately highlight just how absurd this idea of linear causation really is in a complex world, the defense used this brilliant analogy. They said, if someone claims a typhoon in the Pacific was caused by a man breathing in Kunming, it's obviously absurd, right? I mean, sure, from a super strict physics standpoint, every single breath technically moves air molecules and alters the atmosphere, but holding a random guy legally responsible for a hurricane, that completely ignores the massive leap between scales. And honestly, that sets up our central theme perfectly.
Okay, let's dive into part 1, the accusation, and the idea of the social media butterfly.
The whole legal claim here boils down to a very linear assumption. They're arguing that a single retweet from an inactive account with fewer than 100 followers directly resulted in severe public disorder. Traditional law loves this kind of logic, you know? A directly causes B. But in complex systems physics, what the law is actually doing here is taking a tiny microfluctuation, basically just a single piece of background noise, and declaring that it caused a massive macro phase transition, kind of like a whole lake instantly freezing into ice. As we're going to see, physics tells us that complex networks absolutely do not work this way.
Which brings us to part 2, the micro level, where things either branch out or just quickly die.
To really get what happens when an average user clicks forward, we need to introduce our first scientific concept, the Galton-Watson branching process. This is a classic mathematical model used to figure out how things spread, whether we're talking about a virus or a retweet. Basically, it calculates the survival probability of a cascade by looking at how many sub-forwards a single forward will realistically generate. Will the chain actually grow, or will it just fizzle out?
And honestly, here's the massive punchline for this specific case. When you plug in the parameters for an account with under 100 mostly inactive followers, the expected branch number, what physicists call R0, is roughly 0.05. For any cascade to actually grow, that number has to be greater than 1. At 0.05, this network isn't just subcritical, it is in a deep, deep subcritical state.
So, what does an R0 of 0.05 actually mean in the real world? Well, it means the expected total spread is literally just 1.05. A viral avalanche from this specific user is mathematically impossible. A subcritical cascade dies out with a probability of exactly 1. It doesn't trigger some massive chain reaction, it just fades into the background noise of the internet almost immediately.
Moving right along, let's step up to part 3, the Meso-Level. This is all about hubs and edge nodes.
You might be wondering, how does the actual architecture of the network treat different users? Well, social media platforms are built on a very specific mathematical structure called a scale-free network. This is a system featuring extreme massive inequality. You have a tiny, tiny fraction of nodes with millions of connections, and the vast majority of nodes have practically none. It's literally the ultimate rich-get-richer structural environment.
And this brilliantly illustrates the staggering divide we're dealing with. On one side, you've got hub nodes. Think major media accounts, celebrities, platforms with massive influence. They act as the central wiring for the whole network. But on the other side, you have edge nodes. A user with fewer than 100 followers? That's an edge node. In terms of network dynamics, they have absolute total statistical insignificance. Because of this wildly skewed structure, complex networks have this property called network robustness. Basically, if you randomly delete an edge node, it has almost zero structural impact on the entire system. It's exactly like turning off a single light switch in a suburban house. It is definitely not going to crash the national power grid. The system barely even registers that the edge node is gone, let alone that it clicked retweet.
All right, stepping up again. Part 4, the macro level, and what we call the illusion of order.
So the legal claim pushes this idea that public order was disrupted.
But what does order actually look like on a global internet? To answer that, the defense brought in the CAP theorem from computer science. This theorem beautifully proves why a perfect, orderly system is an actual physical illusion. It states that a distributed system, like a massive social network, cannot simultaneously guarantee consistency, availability, and partition tolerance. You can only pick two.
Let's break those down real quick. Consistency means everyone sees the exact same data at the exact same time. Availability means the system always responds. And partition tolerance means the system keeps working even if parts of the network lose connection. Because network drops happen literally all the time, platforms have to sacrifice perfect consistency to stay available. What this proves is that distributed networks are inherently and naturally a little disordered and asynchronous. That background chaos, that's just a feature of the system, regardless of what any individual user does. Okay, zooming out to the final structural scale, part 5, the system level. Let's talk sandpiles and avalanches.
So if a random retweet doesn't do it, what actually causes a massive society-wide disruption? Enter this absolutely gorgeous concept called self-organized criticality, or SOC. This theory explains that certain systems naturally evolve over time to a highly precarious critical state. Think about dropping grains of sand onto a table. It slowly builds into a pile, getting steeper and steeper, until it hits this exact critical angle. Once it's at that critical state, it becomes unbelievably sensitive to even the tiniest perturbation.
And it really makes you ask, is it the last grain of sand that causes the avalanche? Or is it the critical structure of the entire sandpile? Think about it. If the sandpile isn't already at a critical state, 99.999% of fluctuations, those falling grains, simply disappear and do nothing. For a real avalanche to happen, the entire system must already be structurally primed for a collapse.
So, what this all means, and what the defense brilliantly pointed out, is that a micro-fluctuation is absolutely not a macro-phase transition. Conflating those two things is a fundamental category mistake in statistical physics. The background noise of a system, like a random retweet, is just a fluctuation. A system-wide collapse is a phase transition. You simply can't legally blame the microscopic noise from macro-level disaster without proving the system was already at a critical state and that this specific noise was the exact trigger.
Which brings us to our final showdown. Part 6, Science versus Legal Logic, the grand finale. When we stack these two worlds side by side, the mismatch is just profound. Traditional legal logic loves to be linear, A causes B. But scientific causal modeling knows that complex networks are inherently nonlinear and systemic. The law uses these highly subjective labels like severe disruption, while science demands strict mathematical, statistical thresholds. The law makes categorical assumptions about behavior, whereas science knows that an outcome is entirely dependent on the critical state of the whole system. Blaming a 100-follower account for a network collapse is literally like blaming a single water molecule for moving a piece of pollen. It is statistically completely irrelevant on its own.
So, what's our core takeaway from this explainer today? It's that modern justice must distinguish between some abstract universe influence and provable systemic causality. Look, just because every action technically exists in the universe doesn't mean it bears legal responsibility for macro chaos. The justice system simply cannot punish micro actions by pointing to a macro-level disaster unless they can definitively, scientifically prove the causal chain that connects them. And I want to leave you with this final, really provocative thought. If our modern social networks operate on this quantum-level, complex system physics, can our justice system really survive if it keeps relying on Newton-era linear models of blame? How must the law adapt to the age of complex networks? It's a huge question and one we all really need to be thinking about. Thank you so much for joining me on The Explainer today, and I will catch you next time.